you very much, Hans. So I am the starter. We have a three-course meal for you. I'll be looking at some examples of pay-for-performance energy efficiency programs in the building sector. Then we'll move to Mark Lister, who will go into more detail on the way in which energy savings can be measured and verified. And finally, we'll move to Claudia, who will elevate the discussion to the strategic level and put it in the context of EU energy efficiency policy. Okay, well, we'll start from here. So the work I'm going to report on was done as part of the SENSEI project. SENSEI is funded by the Horizon 2020 EU framework program for research and innovation. And SENSEI looks at pay-for-performance schemes for energy efficiency in the building sector. So this is a concept that's already well in place in the industry sector, where it's used in many of the energy efficiency obligations, for example, that are in place across the EU. And these pay-for-performance schemes are innovative ways to provide finance for energy savings. And in the building sector, they're mainly used in the US. So the SENSEI project is looking to essentially elaborate pay-for-performance schemes that can be implemented in the EU context. And the presentation today is based on the report you can see on the screen there, which was published as part of the SENSEI project, which looks at experiences and lessons learned from pay-for-performance pilot schemes. And Hans, maybe you can just take the controls because my controls don't seem to be operating very effectively here.
Okay, let me do that. Then just tell me what I should do.
Okay, so next slide, please. So the motivation for the work essentially stems from two challenges. So one is the need to increase the energy efficiency of the EU's building stock. And at the moment, the renovation rate within the EU is remaining stubbornly low. And in addition, a recent report from the EU Court of Auditors noted that many subsidy programs do not focus on cost effectiveness to a great degree. So we have a real challenge in terms of both increasing the renovation rate, but also doing it cost effectively. Click, thank you. And the other challenge relates to the future energy system that will be in place in the EU, in which a lot of the energy consumption within buildings will be electrified, and that electricity will be based on renewable energy. And in that context, buildings can help to reduce peak energy consumption through energy efficiency, but also to provide flexibility services to enable the grid to operate effectively. So we have twin policy challenges to tackle. How can we increase the impact of buildings' energy efficiency policies, providing better value for money for taxpayers and bill payers, but also for building owners and the tenants who have to live with the consequences of energy efficiency interventions, good and bad. And secondly, how to put in place a system for rewarding buildings for providing services to the energy system. And as that issue becomes more acute, we're likely to require more certainty over the impacts on energy consumption in order for the energy system to be willing to pay for energy efficiency improvements. Next slide, please. So our review of international experience with pay-for-performance focused on 11 case studies. These are mainly in North America. Click. And these case studies are all driven by public authorities or public bodies of one sort or another, so system operators, or they're delivered by a utility that is being directed by a public authority. And often these are in the case of what in Europe we call energy efficiency obligations. So obligations on utilities to deliver energy efficiency savings. Next point. And the large majority of these target large commercial buildings. You can see that's the top section of this chart. But there are also some interesting developments in both the small commercial building sector and indeed the residential building sector. Next slide, please. So just briefly, what is the difference between a traditional subsidy scheme and a pay-for-performance scheme? So in a traditional subsidy scheme, payments are made based on deemed savings. So an assumption is made ex ante, so before the measures have been put in place, about what savings you will get, and a one-off payment is usually paid upon installation, potentially after some quality checks, but not always. Click. Whereas a pay-for-performance scheme, this is the key difference. So the savings are established by comparing metered energy consumption to counterfactual energy consumption, which is basically a baseline based upon previous energy consumption adapted to reflect other changes that will have affected energy consumption. And Mark will go into more detail in his presentation about these measurement and verification protocols. And the payments are then made proportional to the energy saved, so as the savings occur. Next slide, please. So how do the cash flows work in this system? Click. So in a traditional subsidy regime, the subsidy is made in period 0 alongside the investment. And then in future periods, energy bill savings reward the tenant, the occupier of the building, who may or may not have made the original investment. And those energy bill savings continue through many periods into the future. Whereas in a pay-for-performance program, the investment is obviously made in period 0, but the pay-for-performance payments are only made in future periods alongside those energy bill savings. So this is a very, very high-level illustration. Let's have a look at how these performance payments issues are dealt with in our 11 case studies. So next slide, please. So on the performance side, well, overall, the performance rules are quite similar across the examples we've reviewed. And usually the programs are quite flexible in terms of which measures are eligible. And this really is a key feature of pay-for-performance programs, because having that flexibility allows the aggregator or the company that's getting the subsidy to vary what they do in order to maximize the returns. So this might be in terms of installing different technologies, but it also might mean focusing more on providing advice on how to operate those technologies. It might involve maintenance of those technologies, or it might involve some behavioral measures, all of which should enable greater savings to come from the energy efficiency measures that are being installed. They often use smart meters to collect data before and after the measure, although smart meters are not essential. And the end beneficiary of the subsidy is sometimes the building owner, but in other times it's aggregators that receive the subsidies directly from the utility, and then the aggregator will have its own contract with the building owners, and that contract between the building owner and the aggregator doesn't necessarily have a pay-for-performance structure. So the incentive is upon the aggregator to make the highest amount of energy savings they can, taking account their cost structure. And then the payments, so the payments are proportional to the energy saved. In some of the programs, the payments were also twinned with an upfront grant. And clearly, this is about sort of offsetting the risk to the aggregator or the energy efficiency service company, because the key, one of the key aspects of pay-for-performance is that the performance risk has been shifted from the government or taxpayers or bill payers onto the energy efficiency contractor, and at times, at times, the risk for the aggregator is too great, or it's too great for their cash flow. So often there is a grant that is applied alongside the pay-for-performance structure. The prices per kilowatt hour or per therm are set in advance, and sometimes these are published in advance of bids being asked for, and sometimes they're the result of individual negotiations. Sometimes there are bonuses for particular measures, and the payments are made over a period of between 1 and 5 years amongst the 11 programs that we looked at. So next slide, please. We're now going to look at a particular example. And the example I've chosen is one in the residential sector. And I thought this would be the most interesting one to look at, given that this is perhaps the most, I guess, or unusual of the programs. The ones that deal with commercial buildings, I guess, are the ones that are closest to current practice in the industry sector. And the example in the residential sector is in California, where the utility PG&E runs a residential pay-for-performance program. And in this program, they contract with aggregators to deliver savings across portfolios of houses. And they use the CalTrack method for measurement and verification. I should say that most of the programs we looked at used the IPMVP method that Mark will talk about, but CalTrack, which is similar in many respects, is used in 2 or 3 of the programs. And then the payments, so click please. So the payments are 100% proportional to the energy saved. So there is no upfront grant. However, the payments are paid monthly. So initially they'd wanted to pay only after a period of 1 year, but reflecting the point I made earlier about the need for the aggregators to have a consistent cash flow, they decided to change the payment structure and make it on a monthly basis over the 2-year period. And another crucial aspect here, prices are based on the expected lifetimes of measures. So this means that measures with longer lifetimes, such as insulation, are rewarded proportional to their lifetime savings, which means that some more technical measures get put in place as opposed to just behavioural measures that will have an impact over the 2 years of the programme. So next slide, please. So we made some recommendations on the basis of these programs, which, as I said, were mostly in the US. And the first thing is to say that we should begin piloting pay-for-performance programs now in the EU. And we say piloting because this is conceptually appealing in the building sector. There are potential some real long-run benefits in terms of getting the building sector in shape to provide energy systems services to the grid. But we need to have much more evidence on the costs and benefits of bringing this type of measurement and verification-based approach into the building sector, and look at that evidence before we roll it out in much wider programs. So we need to start small and build upon experience. And clearly we need to integrate well with broader climate and energy objectives. A good example of this we found was in the District of Columbia in the US, where the pay-for-performance scheme also helped building managers to comply with their obligations on building performance. Next slide, please. We also stress the importance of setting good measurement rules for energy savings. And this isn't just about the measurement and verification protocols, but as Claudia will no doubt say, there are rules associated with member states reporting energy savings to meet their obligations under the EU's Energy Efficiency Directive. And the acceleration of the smart meter rollout is not absolutely essential for pay for performance program, but it is certainly a great help in terms of managing the costs of measurement and verification protocols. And final slide. So something which we found when we interviewed people who were working on these pay for performance programs was a need to adapt the pay for performance schemes to local conditions. I mentioned what happened in California, where, you know, during the pilot, the payment structure was changed. Involving stakeholders in the program development is absolutely essential. We heard from in the District of Columbia again that there was some confusion initially amongst the energy efficiency community, who were bidding for different programs, some with pay for performance payment schedules and others more straightforward subsidies. So being really clear about your, you know, what your programs are offering. And finally, absolutely essential is that when these programs are piloted, they are done so in a way that ensures that evaluation evidence is collected and the results can be shared so that others around the EU can build upon what is being done amongst the leaders in the EU in this space. So that's my hors d'oeuvre. We're now going to move to the main course, which is about how measurement and verification protocols actually operate and can be useful in the EU context. So I'm now going to pass over to Mark, who will deliver the next presentation. Thank you.
Thank you very much, Sam, and thanks also to Leonardo Energy and the Users TCP Academy for having me along today to speak. Good morning to all of you there, and I'm not sure how much of a main course I'm going to be or how hungry you still are, but we'll definitely go ahead and follow on from what Sam's been talking about to introduce to you the organisation that I chair, the Efficiency Valuation Organisation, which, as you can probably tell from the name, is very relevant to this discussion. The pay for performance schemes that Sam's been talking about have a lot of promise, not just in Europe, but around the world. And obviously the question comes up immediately when looking at this issue of how to roll out pay for performance schemes and have them applied through policy. There needs to be a consistent basis for measurement, and there needs to be a way of, I guess, instilling confidence in the actual performance achieved for those schemes to work. And I have a lot of material that I can go through, but I'll try to keep it quite quick so that we can leave time for your questions. But the good news is that the Efficiency Valuation Organisation and the International Performance Measurement and Verification Protocol, IPMVP, which is a big mouthful, actually provides the bedrock for understanding measurement and verification globally. And it's a tool that I think has a lot of application to policy and policymakers thinking about how to actually roll this out across an entire continent in the case of Europe. So what is the EVO, as we call it for short, but basically an organization dedicated to this question about M&V, monitoring, measurement and verification, I should say. So been around for 25 years and has developed over 20 years ago, just this year, this IPMVP protocol, which sits behind most of the sort of the globally accepted principles of measurement for energy efficiency projects. It's an organization led by volunteers around the world, and it's basically, as I said, dedicated to the M&V question, and probably the only organization that has that as its core mission and nothing else. So in terms of the work that it's done and the protocol itself, as I mentioned about 20 years ago, put together the guidelines and the rules around this. So IPMVP is, I think, a globally accepted set of principles. EVO'S providing training and certification on these principles in over 60 countries. And the overall protocol is very detailed. I can give you a little bit of a sense of how detailed just as we go through this, but really it's a framework that can be used to define the entire concept of savings from performance. It's really looking at how do you create the sorts of plans and regimes under which pay for performance schemes and other energy services contracts, performance contracts can thrive while remaining flexible and being adaptable to different situations, different information availability, different requirements, and so on. And this is a list of the sort of benefits, but I think it's what I've been saying around standardizing approaches, standardizing across different countries, standardizing across different markets, and legitimizing these sorts of projects through recognition of energy savings on a consistent basis. It also provides some important points around the trade-off here between costs of program administration and measurement and the accuracy. I'll come back to that point. But it's also a way of creating this replicable basis on which to structure a program, particularly where you're dealing with multiple market environments, such as you would be in the EU. So in terms of the suite of products, just very quickly to go across the top of the slide on the left-hand side here is the IPMVP, what we call core concepts, which is really the sort of the guiding principles or the Bible of the measurement and verification issues. There's a lot of specific application guides been developed, and this covers the use of renewables in buildings, other things like, for example, just recently, and it's in dotted line on this picture, but only just a few weeks ago, we completed the application guide for non-routine events, such as, for example, global pandemic, which is the sort of thing that we need to be able to have a structure for understanding and building in where things outside of the norm happen. So the science and the engineering behind this is tried and tested over a long period. And this is the sort of I suppose the collected wisdom that practitioners from around the world have brought to this over 20 years. So there's a range of different areas. I would point also to the other side of that diagram on the left, the International Energy Efficiency Financing Protocol. So actually linking these guidelines and rules, I guess, and application guides for measurement and verification to then the needs and requirements of financiers. So that side of it is also covered. We've done work as well on advanced M&V techniques. You may have heard about some of those where people claiming that M&V can be short-circuited and done more quickly. EVO'S released an entire guide on those sorts of techniques and models. There's many of them out there. And so we're basically sitting across the M&V issue globally and through our community, which is very large, of M&V practitioners. We're basically sort of across most of these issues and positioned to I suppose support many markets on these questions. Just on the right hand side there, you can see we've also done a lot of work with the ISO organization, embedding these core concepts into the different standards that are out there for different areas related to energy management, related to savings and so on. So it's very much, I suppose, embedded in general practice across standards in a range of different ways. So I don't have time to go into all of this, and I won't read it out in detail, but there are 4 key methods within the IPMVP. One is looking at retrofits in isolation. One is looking at whole facilities. And within that, there's a couple of different pathways, one being about just measuring key parameters for a retrofit versus measuring all parameters. And then on the other side of it, where you're looking at changes across an entire facility, the way to actually consider metered information and make adjustments for all the things that would then simulate a baseline or a sort of business as usual energy use versus actual energy use, and be able to actually unpick that in a scientifically robust way. Option D I've circled there in red because that one is actually looking at a calibrated simulation. So the difference there for that one is that you may not have a baseline at all. There may be a situation where you have a new building, for example, or something that should, to qualify for a subsidy, be a certain percentage better energy performing than what standard practice would be. So this allows you to generate, using modeling, a simulation of the building that would then allow you to still create a solid estimate of what savings might be. So there is a lot of science and a lot of detail behind each of these options. But I mentioned option D because we're actually just developing a course in French for that to be applied in, I think, France, Belgium, and Switzerland at the moment. And that's something that may be of interest to people on this call in terms of looking at getting more acquainted with some of those options. But that's certainly something that is in demand in Europe at the moment. So as I said, I won't go into that too much. I do want to talk a little bit about costs, because one of the things that's often spoken about with EVO and in terms of the application of these different methods and principles is that it's a high cost for a project to work on all these things and actually come up with a sort of a very detailed measurement regime and a plan for this, which is a detriment to actually doing it. So there's a number of factors here affecting costs across obviously the number of things that you need to measure, the meters that you have, which is why I think Sam also recommending meter rollout is important here, because it will ultimately improve the possibility of having a cost-effective measurement regime. Frequency of measurement, obviously the length of the baseline, how many reporting periods, all of these things are fairly, I suppose, straightforward in terms of understanding the cost accuracy trade-off that you would be needing to make in many situations. And there's, EVO has an entire guide about this question of how much M&V is required. So how much M&V is enough? And this cost accuracy trade-off needs to be made for each and every project. Just to sort of specify and maybe link to what Sam was saying a little bit, this is a general rule of thumb, and it's been made on the back of experience, I suppose, of what people have done and what they've achieved with different projects. But for project-based M&V, the expenditure is expected to be somewhere around the 3% or 3 to 5% of project savings that you would actually need to then expend on understanding and bringing confidence to those savings. What we see a lot of, and we hear a lot of from different organisations saying that M&V is too complicated, it's too hard, it's too expensive. Choosing deemed savings, which is effectively a very low cost for verifying what your performance of your projects will be, and then aggregating them into a program and understanding a sort of a portfolio-wide approach. We see that approach having been taken in many places, places like India through their ESCO EESL, which has been widely successful in rolling out energy efficiency equipment. And we don't actually know how effective that's been in terms of energy savings, because most of their work is based on deemed savings. So EVO has a position paper on deemed savings, and the fact that ultimately, yes, it's cheaper, but it doesn't actually instill confidence for financiers and policymakers in the overall achievements in terms of savings from the programs. There's plenty of others out there sort of touting effective sort of advanced M&V exercises. We're familiar with those guys, and in fact EVO put out an advanced M&V position paper as well, a snapshot on that in January this year, which goes through all those models and talks about their shortcomings and why circumventing actual measurement basically comes with a reduction in quality in basically all cases. So I just saw a question in the chat there about sending the position paper. Absolutely, that's on the EVO website, and that's freely available. So but this is an interesting question, because I think it's sort of where the rubber hits the road, if you like, in terms of questions about this, because whilst the IPMVP does set down sort of some rules which are pretty difficult to argue with. They're very robust and so on. The question is how cost effective is it to apply them? And we are working at EVO on that question towards saying, how do we make these well-accepted protocols fit for purpose in terms of being able to be deployed quickly and in a way that's widespread. So they're really important questions that we want to engage with people in the practitioner community about as far as we can. So just to finish off, a couple of minutes about EVO in Europe. There's some detail on this slide just about our partners in Europe. So we have training partners across France, Belgium, and Switzerland. That's AFNOR. Fire of Ures in Italy. We have the Portuguese Energy Agency, Energy Lab in Spain, Inviditec in Germany, and ESTA is in the UK. And we also have partners in other areas like Austria and a couple of other countries. So the training that we have on MMV is currently available in the languages shown there on the slide, so about 7 languages, and we've trained 4,000 people in the last 12 years in Europe. So there's actually a very strong practitioner base in Europe looking towards the questions of, you know, how you could actually mobilize and deploy a consistent and effective approach to measurement across the different markets through EU-wide directives and so on. The chart on the right just shows how many active CMVPs, which stands for Certified Measurement and Verification Professionals, active in each country. So you can see that the larger countries, Spain and France and Italy in particular, have got quite a large number of qualified people who are active and engaged in these issues. Germany less so. That's something that we're working on, and there's a number of professionals around Europe who are specialising in these issues and understanding, you know, maybe how to apply them. So just to finish, my last slide is about opportunities next year. As I think I've said along the way, there's opportunities for standardization of process between countries for these sorts of pay for performance schemes in support of consistency for these commercial industrial energy efficiency rollout programs particularly. There's a number of courses that will be run next year, which are all included on our website, which is listed there as well. And they're training courses, as I mentioned, option D, a calibrated simulation course that we have. There's some planning courses, and also courses on project financing. So those are being run largely online given the situation, but they are also run face-to-face in more normal times. And that's sort of an ongoing calendar. And as I said at the bottom there, we're really looking for markets where we can adapt this suite of tools and protocols to market needs in particular places that help to reduce costs and meet the needs of program rollout. So we welcome your engagement on all of those questions. And so with that, I'll thank you for listening. My details are there if you'd like to get in touch. And I'll hand now to Claudia to talk to us from, I think, to be the dessert, the last course, and to talk to us from the, I suppose, the perspective of the policy making in the EU. So over to you, Claudia.
Thank you very much, Mark, and good morning, or maybe already good afternoon to everyone. I'm sorry for joining late, but I was speaking in another event, so I hope I will not be repeating something that has been already maybe just mentioned passing by the previous speakers. So I would like to indicate that, as you are certainly aware, the Energy Efficiency Directive, as amended in 2018, stresses the importance of monitoring and verification rules for the implementation of energy efficiency obligation schemes and alternative policy measures under Article 7 in particular. And these could be found in Article 7 itself and in Annex 5 of the ED as amended, and in addition also in Recital 42. And the rationale for this is to provide confidence in the totality of the policy measures. And obviously, or let's say, while monitoring and verification are really central as regards Article 7, and they are therefore very precise in relation to these provisions. Monitoring and verification are also important and needed for other provisions, such as Article 5 on the renovation of central government buildings and alternative schemes. And even here, it is useful when member states apply the monitoring and verification technologies that were developed for Article 7 in the area of buildings. And the key requirements for a strong monitoring and verification system are to audit a statistically representative sample, to ensure independence of auditors, to ensure that materiality and additionality criteria are met, and to explain how high quality of individual actions is ensured, and that would be for all policy measures implemented. And then finally, clear rules about penalties and sanctions in case of non-compliance. So what does statistically representative means? Its meaning depends to a large extent on the number of measures considered and other framework conditions of the individual measures that are implemented. And therefore, it is not really possible to provide a generally valid definition, for example, a percentage or a number of cases. The aim of this requirement is, in fact, to check that the energy savings are actually achieved as reported, and it is therefore crucial to select a statistically representative sample that could represent the characteristics of the entire population, in this case, obviously, energy efficiency measures, with sufficient accuracy. And since we consider monitoring and verification systems as a very important element, which also contributes to the success of and the confidence in energy efficiency improvements to core, I would like to recall that the Commission services are happy to offer hands-on support via exchange on technical level. And in addition, the Commission published a recommendation on the transposition of the energy savings obligation, which you might find helpful, and this is published on the Europa side. And the recommendation shares practical guidance on monitoring and verification systems, especially as regards the part in the annexes. The monitoring and verification systems should deal with two main subjects. On the one side, monitoring and verification of actions under a policy measure, and on the other side, monitoring and verification of the energy savings as results of the policy measure. And both these aspects could be addressed jointly or separately, and ensuring that the actions promoted by the policy measures deliver energy savings as expected is a key tool for the credibility of the policy measures, and will in fact create the conditions for stakeholders and final customers to have confidence in the policy measures, in the promoted energy efficiency actions, and in the results that are then reported. The requirements to implement monitoring and verification rules are important, not only for ensuring a strong monitoring and verification regime in itself, but also as regards the following aspects. First, ensuring and showing materiality of energy savings. Second, ensuring additionality of energy savings. And third, methodological issues related to the accounting of energy savings. Showing materiality means that a member state can prove that energy savings are the result of a specific policy measure which has been implemented for the specific purpose of achieving energy savings. And the proper monitoring and verification system will support member states in showing the intervention effect of a certain policy measure. And a well-functioning monitoring and verification will also help a member state in showing to the market actors how the policy measure or a program done by an obligated party is intended to provide actors and final consumers with support to overcome possible barriers to the implementation of energy efficiency actions. As regards the additionality requirements, the monitoring and verification system should act as a sort of quality insurance and help detecting possible weaknesses in the policy design or unexpected trends. For example, by detecting action types for which there is an unexpected high free rider effect or rapid changes in the market trends. And then the final point regarding these three important elements regarding the accounting of energy savings. A well-established monitoring and verification system established favorably as an online platform with access granted to all relevant stakeholders can help member states to keep it clear which savings are new annual savings, total annual savings, or cumulative energy savings from all policy measures. A well-designed IT platform can be used for multiple purposes, setting up a platform as anyway a minimum upfront cost. The platform can be used in a cost-effective way to include, for example, several functionalities in the platform. These can significantly reduce the running cost of the monitoring and verification system with a very good payback period after a few years. And an IT platform could, for example, provide some of the following functionalities. There could be some enabling on-demand sampling. It could enable automatized checks. It could enable the test or single identifiers to avoid double counting, and more generally, the data sets that are gathered in the IT platform can provide the part of the data needed for ex-post evaluations. So I think that I will stop here, and I'm happy to answer to questions if useful.